will discuss to you the second law of thermodynamics.
So, the laws of thermodynamics define fundamental physical quantities, which is the temperature, energy, and entropy that characterize thermodynamic systems.
But first, let's define the three laws of thermodynamics. The first law, or also known as the law of conservation of energy, states that energy cannot be created or destroyed in an isolated system.
And the second law of thermodynamics states that the entropy of any isolated system always increases.
And lastly, the third law of thermodynamics states that the entropy of a system approaches a constant value as the temperature approaches absolute zero.
The second law of thermodynamics says that the entropy of any isolated systems always increases. Isolated systems spontaneously evolve towards the thermal equilibrium, the state of maximum entropy of the system. More simply put, the entropy of the universe, which is the ultimate isolated system, only increases and never decreases.
Here is an example of a heat engine using the second law of thermodynamics. A heat engine absorbs 2,500 joules of heat and discards 2,100 joules of heat. Calculate the work by this engine and its thermal efficiency. To calculate the work performed by this engine and its thermal efficiency, let's say this box represents the system. Now, 25 joules of heat energy enters the system, so this is Q sub H, and 21 joules of heat leaves the system, so this is Q sub C. What is the work output of this system?
The work is basically the difference in these two values. If 25 joules of energy enters the system, for it to maintain its state, 25 joules of energy must leave the system. Otherwise, the temperature of the system keep on going. That could be damaging, so the work is gonna be different between Q sub H and Q sub C. In this case, is going to 400 joules. It's 2,500 minus 2,100. Now, what about the efficiency of this engine? The efficiency is basically the work divided by Q sub H times 100%. So it's gonna be 400 divided by 2,500 times 100%. Now, 400 divided by 2,500 is 0.16 times 100%, so this device is 16%. Efficient, so what that means is that 16% of the heat energy that travels through the system is converted to mechanical energy. The other 84% is expelled to the environment, so 16% travels this way and the other 84% escapes to the environment.
A simple way to think of the second law of thermodynamics is that a room, if not cleaned and tidied, will invariably become more messy and disorderly with time, regardless of how careful one is to keep it clean.
When the room is clean, its entropy decreases, but the effort to clean it has resulted in an increase in entropy outside the room that exceeds the entropy lost. So the second law states that there exists a useful state variable called entropy, or the symbol S. The change in entropy delta S is equal to the heat transfer delta Q divided by the temperature T. And the formula for this is that delta S, or the change of entropy, is equal to delta Q, or the change of heat transfer over the temperature, or the symbol T.
For a given physical process, the combined entropy of the system of the environment remains a constant if the process can be reversed. If we denote the initial and final states of the system by I and F, so the formula for this is final entropy is equal to initial entropy, which can also be called reversible process.
The second law also states that if the physical process is irreversible, the combined entropy of the system and the environment must increase. The final entropy must be greater than the initial entropy for an irreversible process. And for the formula for this is the final entropy is greater than initial entropy, or also known as the irreversible process.
And that was the second law of thermodynamics. Hopefully, you have gained knowledge through this tutorial. Thank you for watching!